To solve problems. Investment. Mr. and Mrs. Mitchell are saving for their daughter's college education. They invested $10,000 in an account that pays 4.5% interest compounded continuously, with the goal to have twice the amount in the account in 10 years. There are two questions, but first of all, in this slide, I'm going to talk about the first question, that is, will the Mitchells reach their investment goal in 10 years? So first of all, let's take all the information that we have. So what we have here is principal is 10,000, but let me write here the amount A, and the principal is 10,000. So it's 10,000. And constant, Euler constant E is E. R is 4.5%, but when I divide by 100%, I get here 0.045. 0.45. And time T, the time for how many years is going to be invested. Here is 10 years, time 10. And now we are using calculator to solve this, to get this information. So now we have 0.045 time 10 is equal, then we go in EX here and we got the number, then we multiply it with the principal 10,000 and we get the formula, which is we get the number which is 15,683. So it's 15,000, let me see again, 683. .12. But as we see here, those are not doubling the account, so is a less. And now we already answered in this question, so is not reaching their goal. So now let's go to the second question. But second question here, I'm going in the second slide, and let's read the same question. Number 2. What interest rate is required for an investment with continuously compounded interest to double in 10 years? So we already saw the formula for compounded continuously interest is A equal with P times E in exponent RT. So we want to double. If we double means this amount, if we are investing $10,000, then in account should be 20,000. So that's why instead of A, we are writing here 20,000. And 10,000 was the principal, what they invested, Mitchells. E is here. ER, we are looking for the R. We don't know what is going to be the rate, but the investment is for 10 years. So first of all, this equation we can simplify a little bit by dividing by 10,000 everything. And if we divide everything by 10,000, then we're going to get a 2 is equal with a E, and now here R times 10 is 10R, so it maybe look better this time if I put it in the front, 10R. But still I cannot solve this in the exponential form. We cannot find what is the R. Maybe we can find if we are going in a very, very complex way, very difficult in a difficulties, but still is hard to find. But I think it's much easier if we are using natural logs. Whenever is E involved, we can use the natural logs, and now this exponential form what we have here, according to the definition, we can convert into the natural log. So now this 2 is like, let's say, n, and we can write ln n, but instead of ln n, we write ln of 2 here, and in the other side, the exponent goes down, is x exponent, which is a 10r is exponent. And now everything we divide by 10. By 10 we divide. And r is going to be equal with the ln 2 ln2 divided by 10. Just let me write this a little longer. And this is going to be this way. So now let's use the calculator. So ln2 is 2 ln, I got the number, divided by 10. We get a 0.0 is a 0.0693. Let me see again. 147. 147. But if I want this to convert into percentages, I will multiply by 100%, and R is going to be equal with a 6.93147%. So if the Mitchells invest $10,000 for 10 years with a percentage of 6.93147, they're going to get approximately, they're going to get around $20,000.